All right, hope everybody's having a good day, ready for a 3-day weekend. Uh, let's see, you got your homework you picked up today over solving trig equations. That's going to be due Wednesday. On Wednesday, I'm also thinking we're going to have ourselves a short little quiz, just as some extra practice to make sure that you're ready for the test on Thursday of next week.
Teachers, please pardon this interruption. Please excuse the students who are coming in from the Lomax Center. Their bus was running late and just dropped off about a minute and a half ago. Again, please excuse students coming from the Lomax Center as their bus just arrived. Thank you.
Okay, so again, as of right now, we're still going to have the test on Thursday, and then probably for a day or so after that, I'm going to go ahead and show you how to solve those problems that don't really end up with a special right triangle. We're going to see one of those today, but for right now, we're going to approximate it. On Tuesday, what I'm thinking is that whatever we don't finish on the lesson today, we'll go ahead and take care of, and then we'll have the class period on Tuesday to work on the assignment, ask questions, and again, just get some more practice. All right, any questions about what's coming up? Or just any questions, General? Zach? Quiz Wednesday over trig equations. Okay, so homework is due on Wednesday, and then we'll take that quiz. Okay. All right, anything else? Okay, well, let's go ahead and get to it. Now, you notice we have another focus activity. This is number 2. It says verify cosecant squared of x plus 2 cosecant x minus 3 over cosecant squared x minus 1 equals cosecant x plus 3 over cosecant x plus 1. So I thought this was a really good example, not only to keep up with verifying these equations, but also what we're about to continue in the lesson today. The fact that we have a quadratic trig expression here. So it's of the same form as you normally think of when you start looking at the equation of a parabola, ax squared plus bx plus c. So it's just that you have cosecant instead of a variable. Now, one thing, second period was not a big fan of this. First period was a little more receptive. You'll see this more in a lot of textbooks and resources. What people like to do sometimes is just choose a variable and they'll replace the trig function with it. You know, maybe it makes it a little easier. You can just focus on the factoring and then you plug it back in. These resources, I'm not sure why, they always like to use the variable u. Okay, so we're just going to go ahead and stick with that, but the variable itself does not matter. So let's say that u equals cosecant of x. So now I'm just going to replace every cosecant in the numerator with that. So cosecant squared of x would just be u squared plus 2 cosecant x plus 2u and then minus 3. Okay. So see how it just looks a lot nicer? Okay. Personally, I like to go ahead and work with the trig function, but if you like this, please go ahead and use it. Now, I want to factor this. So, does anybody remember the method I like? What does my father drive? He drives a red Mercedes convertible. There we go. Okay, now that's how I like to go ahead and factor it. I'm not going to use it on this because it's a simple trinomial. But again, I want to emphasize, as long as you're able to factor a trinomial, that's what's important. If you like the method, or if you have the box method or guess and check, whatever you prefer. Okay, so let me go ahead and break this apart. Well, the only factors of 3, we know we need a 3 and a 1. The only way to break u squared apart is a u and a u. So what should I put in between them? Should it be plus or minus 3? It should be plus 3. Okay, why couldn't I say minus 3 plus 1? That would still give me negative 3 when I multiply. There you go. It's very, very important where you place your signs because we need a positive 2u when I add those together. Jack. Oh, okay. All right. Well, see, now that I've broken it apart, well, now I'm just going to go back and replace the variable with my trig function. So u plus 3 is just cosecant of x plus 3. U minus 1 is cosecant of x minus 1. Okay, and there you go. So if I were to multiply those two binomials, it should give me that trinomial that we started with. Okay. Now, over, and I'm definitely going to start with the left side because it's much larger and more complicated. But does anybody notice anything now about cosecant squared of x minus 1? It is a difference of squares. There we go. When we break those apart, we get, what do we call it? Starts with a C. Conjugates. Okay. So one positive, one negative. In fact, it would just be cosecant of x plus 1, cosecant of x minus 1. So factoring was a great way to verify this equation because what happens? Yeah, you got group factors here that cancel, and so you're left with what you wanted to show on the right side. Okay. How many people had that completed before we started? Okay, good. Did anybody do anything different? No? Okay, good. Well, we now have 2 focus activities on Tuesday. I've already got a third one ready to go. Like to get 4 in the set, but we'll kind of see how that plays out. 2 weeks from today is already what? The end of the 6 weeks. We're about to enter the 5th 6 weeks. So things are going to start going, a little quicker because it's testing season, all that good stuff. Okay. So what have we been talking about lately? Okay, trig equations, and we've kind of been getting a little more difficult with the equations as we go. The first day we started with just equations where you could isolate your trig function. Okay, go ahead and solve. We're using triangles for everything. And then yesterday we were working on some equations where we were no longer able to do that, so we were having to use some algebra techniques. Specifically, factoring was a really useful one to us. And there was also another property that we used. Started with Z. The zero product property, right? Okay, that came up very useful. And then we saw our last one yesterday where the factoring would not have helped us. There was no way to isolate a single trig function. So in this type, we had to use an identity to manipulate the equation and solve from there. In fact, yesterday we got down to cosine of x equals 0 and cosine of x equals -1/2. So how many people had the opportunity to go home last night and solve for those? I'm looking for 4 answers. Let's start with the first one. Cosine of x equals 0. Okay, at this point, we recognize it as a what? That is a what? Quadrantal. We are not able to create a triangle on that because we can't have a side length of 0. So think about the 4 ordered pairs of the quadrantals we have on the unit circle. Which ones would have an x value that's 0? Pi over 2 and 3 pi over 2. Okay, so those are the 2 answers for the first equation. But let's kind of talk about the second one. Cosine of x equals -1/2. Does anybody know what those answers should be? Okay, Aiden says 2 pi over 3 and 4 pi over 3. Is there anyone who can verify that? Okay, so I will verify that and say, yes, that is correct. 2 pi over 3 and 4 pi over 3. Okay, so let's talk about how we got that. What quadrants, Raphael, would I go ahead and draw some triangles in if I wanted to solve and get those answers? Okay, 2 and 4? Okay, 2 and 4. Now we're halfway there. 2 and 3, there we go. All right. Now, how do we decide what quadrants we're going to draw our triangles in? Like, why did he decide on 2 and 3? Because of the sign. Okay, where is cosine negative? So I'm going to draw terminal side there and there. Okay. All right. Now remember, the thing about these triangles, when you're drawing them, we always start rotating from where? Standard position. So I'm looking for this one, and I'm looking for this one right here. Okay. We'll go ahead and fill in the sides using the ratio. Let's see, cosine is always what over what? I always forget. Because I'm old. So it's x over r. Okay, so this would be -1, the side that the 2 triangles share, and then the radius is 2. And we've actually seen this quite a few times over the last couple of days. What's the remaining side? Square root of 3. Negative square root of 3. Okay. So what type of triangle is this? It's got to be a 30-60. The only question, Erica, this reference angle that I need, is that the 30 or the 60? That would be 60 because it's across from the longer leg. 30 has to be across from the shorter leg. So this one would be 60 as well. And remember, how I do it is not necessarily how you have to do it. Find what works best for you. In my diagram, I like to work with the degrees, and then I convert that for my final answer. Okay. So, Jasmine, how far would I have to rotate to this first side to have a reference angle of 60 left over? Oh, basically 180 minus 60. 120. So that one right there would be 120. And then, Jack, help me out with the other one, the 180 plus 60.
30.
Ooh, a little higher.
Oh, 240.
240. There we go. So if I take those two answers, 120 is 2 pi over 3 radians, and 240 is 4 pi over 3 radians. Okay. All right. And remember, your answer, whether you're going to put it in a general form, like if you're going to add 2 pi into it, or if you're just going to give me the exact answer here, depends on how it's stated. If you're given an interval, you're going to give me the exact answers. Okay. If no interval is provided, that's when you'll give me the general. Okay. All right. Well, good. Good. Well, let's take a look at a few more quadratics. Starting with this one right here. 2 sine squared of x minus sine of x minus 1 is equal to 0. Okay. So this trig quadratic, I want to go ahead and factor in, which will allow me to use another property. Now, on number 11, I'll go ahead and kind of run through the my father method. But on this one, it may not be necessary unless you guys want me to do it. So Zach is shaking his head yes, so I will go ahead and do that. All right, so what does it mean? My father drives a red Mercedes convertible. What does the M stand for? Multiply. Whoop, multiply. Drop my pen. So what am I going to multiply? The 2 times the negative 1. We always multiply the leading coefficient times the constant. So that is a negative 2. Now the F in father stands for... What's that, Chris?
What? No, never mind.
No? What was it? Did someone say it? Maybe I didn't hear it. Factor. I can't say any sort of factor. Just kind of looking at me, okay? So what are the only factors of 2? 1 and 2. This isn't awkward at all, okay? All right. So I got the 1 and 2, but the only question is which one has the negative? Would have to be the 2 because we need a negative 1 here in the linear term. Okay. So now what does that D stand for? What's that? Okay. Maybe that's not a bad idea. Okay, so we multiply, factor, and then we divide. We always divide by the leading coefficient. Okay. And then the R in red stands for reduce. Okay. So 1/2 won't reduce. And that's the only trick to this strategy. If it's something that simplifies and gives you an integer, you still want to leave it as a fraction. So negative 2/2 would just be negative 1 over 1. And now the trick is just to move these values to create your group factors. Okay, so here's my question. Would this be 1 sine of x plus 2 or 2 sine of x plus 1? We always start from the denominator and work our way up. So this would be 2 sine of x plus 1 times, what would negative 1 over 1 give me? There you go. Perfect. Okay. So what were the steps again? We multiply, factor, divide, reduce, move. Okay, that's how we moved these values to the groups. And then the convertible, that C, what's that? Which a lot of people don't do. Check, because you could multiply those back together just to check to see if it is correct. All right.
Oh, I like how the sentence works even without the convertible. My father drives a red Mercedes.
That ought to do it. Really? No one heard?
Yeah.
I said that auto do it. Like, okay, now, Raphael, are you saying, that was bad, or, man, that's bad? So it depends on, it's on fleek, okay? Yeah. Don't get triggered. Y'all still say that, okay, I'm triggered, salty, right? Raphael, did that joke make you salty? Okay, see, I'm up on it, okay? I'll go home and tell Bay tonight. Anyways, okay. Well, let's go ahead and do the same thing to the other one. Let's factor him. Let's practice it, and then we'll come back and we'll go ahead and solve these. Okay. So take about, let's say, a minute. Again, if you like that method, okay, go ahead and use it. If you have your own method, whatever you prefer. But I need to take 6 cosine squared of x minus cosine of x minus 2, and I want to break it apart. Okay. So 1 minute. Okay, so that's actually been a little over a minute. Does anybody have the two groups and would like to share them? Okay. Or let me rephrase. How many people have groups but they're not 100% confident? Okay, Christian, what you got?
Okay, so I got 3 cosine plus 2 cosine plus 1.
Okay, there's only one thing off on that.
Okay.
Your signs.
This.
So it should be 3 cosine of x minus 2, and we're going to go ahead and say cosine of x, oops, excuse me, 2 cosine of x plus 1. Okay. Does anybody want me to multiply those or run through the process to show you how we got that? Okay, so let's say we start by multiplying. What's 6 times negative 2? Negative 12. So I know that one factor is negative, one's positive, but whatever two I choose have to give me the negative 1 in the middle. So what am I thinking? Okay, 3 and 4, and the 4 would have to have the negative. Now I divide by 6. We always divide by the leading coefficient. Okay. Well, what is negative 4/6? Negative 2/3. 3/6 is 1/2. And if I work from the denominator, 3 cosine x minus 2, 2 cosine x plus 1. There we go. Perfect. So Christian's was extremely close. The only difference would have been that his would have given a plus cosine of x. Okay, which doesn't seem like a lot, but it will change your answers. All right. Okay, so now let's go back. In either case, how am I going to solve these? Zero product property. If I'm multiplying two terms and I get a product of 0, then one or the other has to equal 0. So 2 sine of x plus 1 equals 0, or sine of x minus 1 is equal to 0. Okay. And now these are just very simple equations. Let's isolate the trig function. This one here, sine of x equals what? 1. Over here, if I subtract 1, divide by 2. Okay, so sine of x equals negative 1/2. So which of these should I be able to get with no work? The left or the right? Why the right? What's different about him? He's a quadrantal. Okay. He's going to be a quadrantal. So think about these 4 locations here on your unit circle. Which ordered pair or pairs has a y value that's 1? It's on the y-axis, so is it the positive or the negative? Positive. So what radian measure would get me there? Pi over 2. Okay. Does anybody want me to talk about how we knew this was a quadrantal? Does anybody want me to draw part of the unit circle? Is everybody okay with that? Jack, you're good? Okay. All right. Yeah, wasn't it you they trusted yesterday with the bonus? I'm just. He brought it up. I don't even remember. Wasn't it the Elvish rings?
Yeah.
Okay.
Like you were sure it wasn't the rings.
Yeah, it was like, I'm sure it
Yeah,
is.
All right, now the other one. Sine of x equals a negative 1/2. All right, so this one is definitely not a quadrantal. We have a ratio that we recognize, and we're still looking at 0 to 2 pi. How do I solve a problem like this? What do I do? So what quadrants would I draw some triangles in? Okay, I heard 3 and 4. Why?
It's negative.
Yeah, because sine's negative. Okay, that's where sine is negative. So I'm going to draw one here, connect it to the x. Okay. Now, sine's ratio, again, is y over r, the opposite over the hypotenuse. So that'd be negative 1, 2, negative 1, 2. And again, you start to notice the similarity here. What's the other missing side? Square root of 3, so that's a negative square root of 3. Now, I need this angle, but I also need start right. Let me rephrase. Sorry. That angle will help me find what I need. So I need this one, and I need this one. We always start rotating from standard position. So this reference angle that I was just talking about, let's see, Alex, which one is it? Is it 30 or 60?
30.
It is 30. Okay. So that means this one's 30. That's a 3. Okay. So what would this first angle be right here? 210, right? So this is 210. What about the other one? Basically 360 minus 30. 330. Okay. So now let's get the other answers. X equals. So what is 210 as a radian measure? Okay. So 7 pi over 6. Perfect. And 330. 11 pi over 6. That's absolutely right. So on the interval from 0 to 2 pi, there are exactly 3 locations where this equation is going to be true. Is anybody having trouble with the equations? Anybody not understanding any part of it? Okay, again, I think once you get down to this point here where you can draw the triangles, I think we should be okay. It's just getting there that might be difficult for some folks. Okay. Now let's take a look at the other one. Okay, so this is already broken apart for me. So I'm going to have 3 cosine of x minus 2 equals 0. And right here I'm going to have 2 cosine of x plus 1 is equal to 0. Okay. So Kyle, help me out with the first one. What would cosine of x equal? If I add the 2 and divide by 3. I'm sorry, sir? Sorry, I was distracted by someone yelling they're going to go to the bathroom.
Call Palmer.
Oh, Oh, hey.
Call
It's okay.
Palmer. He's out there at the gym.
Hey. No, you're fine. You're fine. I don't know if she's screaming, but she's screaming. That's all. Anyways, what is it? 2 divided by 3, 2/3. She is what?
Triggered.
She's triggered. Something triggered her. Okay. Her emotions are not on fleek. I like fleek. I'm going to keep saying it. Okay. Go home and tell Betty. 2 cosine x plus 1. Alyssa, what would the other one equal if I subtracted 1 divided by 2? If I subtracted the 1 over and then divided by the 2. I'm sorry? What kind of 1/2? Negative, because we'd have to subtract it over, right? Okay. All right. Now, does anybody recognize anything about the right one? Yeah, isn't that the one that we just did? The one that you were going to look at last night? In fact, what did we get? Aiden said it was. Remember, because you were the one who gave me the answers?
Oh, yeah.
Well, it was the one that we did previously? Okay. So 2 pi over 3, 4 pi over 3. So we don't have to, spend time going over that again. We actually just solved it a little while ago. But now this one, I am going to go ahead and walk you through because I believe you have a few on your assignment that's going to do this. Cosine of x equals 2/3. Well, you already probably noticed something's different because we don't recognize that ratio as something we normally see on the unit circle. But that doesn't stop what we're going to do, okay? What quadrants would I go in? 1 and 4, because that's where cosine's positive. Okay, so I'm going to draw my triangles again. Okay. So let's see here. Cosine is always x over r. So these two sides together would be 2. The radius of each would be 3. What's the height?
9 minus 4. 5.
Okay, so square root of 5. And this one would be negative square root of 5. Does anybody want me to go through the Pythagorean theorem to show that? Okay. Okay, so you'll notice it is definitely not a 45-45-90, but it's also not a 30-60-90. Okay, so there is an example of one on the back board where you're going to write out expressions without finding the exact value, finding the decimal. But until we get to that point where I can kind of talk to you about that, for those that show up now, we are just going to go ahead and use the calculator. Okay, so we are going to go ahead and take the inverse. So cosine inverse of 2/3 is going to give me x on this one. Okay. Well, first off, is this even going to work? Because I remember yesterday we had one that didn't. Why didn't that one yesterday work? Okay, it was not on the, what do we call that? Remember, that ratio has to fit on a specific interval, right? In fact, what was the interval? -1 to 1, and 2/3 definitely belongs to that. So we're going to be okay. But here's the thing. This is just going to give me one answer. How many answers should I be getting? Should have 2. So I should have this one right here and this one. Okay, well, why don't we go ahead and first figure out what that one is. All right, so I'm going to come on over here to my calculator. Trig. Ooh, interesting. Cosine inverse. Let's escape out of that. There we go. 2 divided by 3. So what should I get?
Oh, wait. 48.
Okay. Now remember, we like our answers to be given in radians. Okay. So I'm just going to go ahead and take this. I'm going to do this on the keyboard and mouse because it's going to go a lot faster. But I'm just going to take that and multiply it by what? Pi over 180. There we go. So there's my first answer. 0.84. Let's go ahead and round it to 2 decimal places. Okay. So I'm going to come back over here. So 0.84. So let's say x equals radians. But now there's a second angle that we still have to get. And see, I've drawn the red arrow in order to indicate what angle we need. How do I find that? Because we've already taken the inverse, so what do we do now? Take the not inverse? Okay. Well, let me ask you a question. Oh, Raphael, do you think you know? I'm sorry? Oh, you're close. You are right about the subtraction, not 360 minus 2 pi. There we go, because we put it in radians. Because what do you know about these two triangles that we created? They are exactly the same, right? So if this measure is 0.84, this angle has to be 0.84 as well. Okay. So all I did was take the full revolution and subtract off what we don't need. Okay, so let me see if I can just do that here. So I'm going to take 2 pi, and I'm going to subtract that previous one. I'm just going to highlight it. Okay, so what should I be getting? Okay, so let's say it's about 5.44 radians. Okay, there we go. Okay, good. Oh, I don't know what that is. There we go. So about oh, it wasn't 5.4, sorry. Okay, messed up by that thing right there. 5.44. Okay, so there are 4 answers total that we needed to find on the interval from 0 to 2 pi. Okay, it's just that 2 of them didn't come directly from our unit circle that we're accustomed to using. Okay, anybody having a hard time? Anybody not sure where we got that 5.44?
I know how you got it,
Uh-huh.
but what if it's like in the third quadrant? Do you subtract by a certain ratio, or is it always gonna be like?
What if it's in the third quadrant here?
Yeah, like if it was like one of those where it's positive and negative, and it's
Oh, okay. That's one
yeah.
thing you're going to have to think about when you start writing out those answers. So in this case here, just for argument's sake, had the other triangle been over here, then I probably would have taken 180 plus that measure. Or
Okay,
pi
pi
plus
plus,
that, yes.
okay.
Mm-hmm.
Okay.
Does that make sense?
Yeah.
So on those, yeah, we're going to have to get a little creative. We're going to have to make sure we know, is our angle going to be positive or negative? And then from there, how would I get it?
Oh, okay.
Okay. All right, so good. Okay, and this is the last problem that the other classes were able to get to today. So let me pull this down real quick. Okay, so now you're going to notice it says solve on the interval from 0 to 360, and that should actually just be less than 360, not less than or equal to. But even though it has it in degrees, that's the same as what? 0 to 2 pi, yeah, so it's just another way of writing that. So we're still going to give our answers in radians. Now, this equation, we don't have to manipulate it at all. It's already got the single trig function equal to a ratio, but why is this one different? Because it's 2x. These were like those very first equations I showed you, I want to say Tuesday, okay, earlier in the week. So here's the thing. I would really encourage you, if there's any manipulation of x in your equation, to go ahead and always start with the general form. And then use that general form to go ahead and find your answers. You remember how we were plugging in values of n until we got one that was outside the interval? Okay. Now, you don't have to do that on all the others, okay, but I would definitely recommend you do it here because it's really easy to miss an answer if you don't. All right, well, let's go ahead and start here. Let's get somebody up here to figure out what my two triangles are going to look like. So someone will go ahead and diagram them, fill them in, all that good stuff. Who would like to come up and do that for me? Okay, so no hands. Okay. 20. Okay, so Rhett. Rhett says I will come up. Okay. Or someone else 20? Oh, okay. Okay.
You like to make sure
Mm. pretty sure, because that would be 12, 18. Yeah, that's 20. Now, we would go ahead and start the same way. Just pretend it said tangent of x equals square root of 3. So where would we start? Because once we have everything taken care of, then we'll go back and look at the 2x. Okay. So wait, why did he go in 1 and 3? What helped him make that decision? Because it's positive. Those two quadrants are where tangent's going to be positive. Okay, and we just forgot one negative. There you go. So that would be 2. This is a special right triangle. So what's that reference angle right there? Okay. Is he right? I would say yes. Pi over 3 and 4 pi over 3. Okay, so you diagrammed them. Okay, I'll go ahead and take over. Okay. Good, 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 good. So everybody's okay. Let me go ahead and kind of backtrack. This one's 60, correct? So this one's going to be 60 as well. It's across from the longer leg of the triangle. So 60 degrees is pi over 3. So I would go ahead and say x equals pi over 3. And then if I were to come all the way around here, 180 plus the 60, that's 240, which would be the 4 pi over 3, right?
If that was negative, you would have 1 at the second.
Yes, so if it were negative square root of 3, they would be in the exact opposite quadrants. Now, here's the thing. If it was tangent of x equals the square root of 3, we'd be done. We have our answers right there. But it's not x, it's 2x. Okay. So I strongly encourage you to do this. If there's any manipulation, and it could be 2x, it could be 1/2 x, and there are even some different ones showing up on your homework assignment, I would go ahead and write the general form. So before I go ahead and solve for x, what would I add to this to make it the general form? Why pi n? Why wouldn't we do 2 pi n? Okay, remember, if it's tangent or cotangent. So I'm going to say plus pi n plus pi n. Remember, we're always going to say that n is an integer. Okay. No, I mean, as long as it's somewhere at least one time, you don't have to write it every time, but as long as it's there just to indicate, because you're going to be doing the same thing for every problem. Okay. Now let's solve for x. So if I divide through by 2, what's pi over 3 divided by 2? Pi over 6 plus pi over 2n. Or pi n over 2, however you want to do it. Okay. What would it be over here? Let's see, 4 pi over 3 divided by 2 would be...
but do you want us to, like...
Yes. So it would be 4 pi over 6.
And then it will go down to 2 pi over 3.
Yes. And again, plus pi over 2n, or pi n over 2. Okay. Now remember, we're only interested on, for all the solutions, on the interval from 0 to 360, or 2 pi, right? Okay. So I'm going to go ahead and start plugging in values of n, but does anybody notice it? Okay. So if no one notices it, I'm just going to go ahead and start plugging in, and hopefully someone will say something as we go along. Let's start with n equals 0. Always start with 0. Well, that's easy. Pi over 6 plus pi over 2 times 0, that's just pi over 6, right? 2 pi over 3 plus pi over 2 times 0? 2 pi over 3, right? The 0 is always the easiest one to do.
Oh, and then
Okay.
it's just gonna...
So now we've taken care of n equals 0. So now I'm going to move on to n equals 1. Okay, so pi over 6 plus pi over 2 times 1. So that's just pi over 2. But this is what I was talking about. What's going to happen? Okay, now let me walk through. What would be my common denominator? 6. So I got to multiply by 3 over 3. That's going to give me pi over 6 plus 3 pi over 6, which is 4 pi over 6, which is 2 pi over 3. So what was I trying to draw your attention to a moment ago? Which one basically is not necessary? This second one. So we could still go ahead and include him. I mean, we can use him, but I think you're just going to be giving yourself extra work because you're going to be duplicating answers. Okay, so if you realize that this one is giving me all angles coterminal with this one to begin with, we can just work with the first one. Okay, now we've already noticed, does that happen all the time? Tan and cotangent, yes, but not with the others. Okay, not sine, cosine, secant, or cosecant. So let's continue to plug in. We took care of 1, now let's go to 2. Now remember, we can only stop when my answer is larger than 2 pi. Okay. So let's see here. If n equals 2, pi over 6 plus, well, what's pi over 2 times 2? Pi. So that would be 7 pi over 6. Is that less than 2 pi? Yeah. So that's an answer. Okay. We keep going. N equals 3. Okay. So now I'm going to have pi over 6 plus pi over 2 times 3. That would be 3 pi over 2, right? Okay. Well, common denominator would be 6. So I got to multiply again by 3 over 3. So pi over 6 plus 9 pi over 6, which would be 10 pi over 6, which is 5 pi over 3. Is that less than 2 pi? Yes, so that is an answer as well. And see, this is why you want to be careful about those equations where you're manipulating x. Because see, at first glance, looks like we only have how many answers? 2, when in reality, we've already found 4. Okay. So now let's try 4. But I got a feeling we might be stopping here. Because pi over 6 plus, what is pi over 2 times 4? So it'd be 4 pi over 2, which is 2 pi, right? So I don't even need to finish this one. If I take 2 pi and add something, will that be larger than 2 pi? Yes. So I can finally stop there. So I do have 4 answers that are going to work. Okay. Now I can even prove it to you. Okay. 5 pi over 3, what is that in degrees? 5 pi over 3, what is that in degrees? That is 300 degrees, right? Now, the only reason I'm changing it to degrees is because that's what my calculator is in. Remember, these should be values that make the equation true, right? So I should be able to plug in tangent of 2 times 300 and get the square root of 3. If it were in radian mode, then I can go ahead and plug in 5 pi over 3. But what's 2 times 300? That is 600. And let's take a look. You don't have to. Not for this. So if I go ahead and take tangent, if I plug in 600, what do I get? That is the square root of 3. Okay. So see, that's why you got to be careful on those ones that manipulate x or whatever your variable is. Is everybody okay with that? Okay. All right, so definitely look out for those. Other than that, we'll finish up the other one on Tuesday. When's the homework due? On Wednesday, but see, you have the whole weekend. I would encourage you at least go ahead and get it started Because if you wait until, Tuesday, where I am going to give you time in class, maybe we're going to get a good 30 minutes, I'm hoping. I mean, that's not a lot of time, and then you still have to finish it for the next day. So I would at least try to go ahead and get it started, maybe come in with some questions on Tuesday. All right, good. And that is it. We have less than 2 minutes. Let's go ahead and get those calculators.